In 1893, over 120,000 electric lamps illuminated the world's Columbian Exposition in Chicago. The fairgrounds consumed 3 times as much electricity as the entire city. This was presented as a demonstration of new technology. Photographs from the event show something else: an electrical infrastructure that appears fully integrated, distribution systems built into foundations that seem older than the buildings themselves, power networks of a scale that required years to develop, implemented in months. The buildings stood for less than a year. Most were demolished immediately after the exposition closed. A fire in 1894 destroyed what remained. What is rarely discussed is what existed before the construction began. Between the 16th and early 20th centuries, European maps consistently labeled vast regions of Central Asia as Tartary. The term appeared in French, Dutch, British, and Russian atlases. Administrative records referenced Tartarian governance, languages, and trade routes. By the early 1900s, the terminology had disappeared. Buildings attributed to this period share architectural features across continents: domed structures with ornate metallic spires, geometric precision in design, electrical infrastructure that predates conventional timelines. If these observations reflect something other than coincidence, then our understanding of 19th century development requires re-examination. If they reflect ordinary historical processes, then the question becomes why those processes produce patterns that appear so coordinated. The challenge is distinguishing between what changed and what was replaced. Tartary appeared on European maps for over 3 centuries. The geographic designation encompassed areas of Central Asia, Siberia, and at times regions extending into Eastern Europe and the Northern Pacific. The term is derived from the Tatar peoples inhabiting these territories. Cartographers used Tartary as a blanket reference for areas they had limited direct knowledge of. This much is documented in surviving maps and travel accounts from the period. As European powers expanded their geographic knowledge and political influence, the terminology evolved. Maps began using more specific regional names. Administrative boundaries were redrawn. Populations were reclassified under emerging national categories. The transition occurred gradually over several decades. Earlier maps show Tartary. Later maps show the Russian Empire, Ottoman territories, and Chinese provinces in the same locations. What remains less clear is the speed and completeness of this transition. Why certain architectural elements persisted while the terminology disappeared. Why structures built across vast distances during this period share such consistent design principles. The Republic of Tatarstan exists today in Western Russia. Tatar populations continue in multiple regions. The people did not vanish, but something about how they were understood and categorized fundamentally changed. Buildings constructed during the 18th and 19th centuries exhibit distinctive shared characteristics. This pattern extends across Europe, Asia, and the Americas. Domed capitals with similar proportions, exhibition halls with identical structural elements, star-shaped fortifications using the same geometric principles, classical columns and arched entrances repeated in cities separated by thousands of miles. The observation itself is straightforward. Buildings in St. Petersburg share design features with structures in San Francisco, Calcutta, and Buenos Aires. This similarity exists. The conventional explanation attributes this to the spread of Beaux-Arts and neoclassical architectural styles. Architects trained at institutions like the École des Beaux-Arts in Paris designed buildings worldwide. Pattern books circulated internationally. A shared architectural language emerged. This explanation accounts for stylistic similarity. What it addresses less completely is the scale and synchronization, the uniformity of execution across regions with different building traditions, different materials, and different labor systems. Construction records from the period show something else. Projects described as requiring years were completed in months. Materials were sourced in quantities that strained documented supply chains. Labor forces appeared and dispersed with unusual rapidity. The buildings themselves present additional questions. Foundations that extend deeper than construction records indicate basement levels not included in original architectural plans. Infrastructure connections to underground systems predating official municipal networks. These details suggest either remarkably coordinated planning or structures adapted from existing foundations. The elaborate decoration characteristic of 19th century architecture appears inconsistent with documented economic conditions in many regions where such buildings appeared. Yet conventional historical analysis provides context. During this period, labor was inexpensive and abundant. Factory systems employed workers, including children, for minimal wages, under conditions now considered exploitative. This extended to construction trades. Large workforces could be mobilized for projects requiring intensive manual labor. Simultaneously, building materials became industrialized. Plaster casting allowed rapid production of decorative elements. Mass-produced terracotta created elaborate facades economically. Bricks were manufactured through mechanical processes. Cast iron could be molded into ornamental forms. Steam-powered sawmills produced standard dimension timbers beginning in the 1820s. The 1830s, introduction of cheap machine-made nails enabled innovations like balloon frame construction. The Crystal Palace in London enclosed 90,000 square meters in 6 months using entirely prefabricated components. This combination created conditions where architectural ornamentation was affordable. The explanation aligns with documented economic history. It accounts for why elaborate buildings appeared during this specific period and why such construction became prohibitively expensive in later eras when labor costs rose and working conditions improved. What it does not fully explain is why observers examining these buildings today find the construction methods difficult to reconcile with the supposed technological limitations of the era. Perhaps this reflects our present assumptions rather than past realities. The 1893 World's Columbian Exposition covered 686 acres with over 200 buildings. Construction began in late 1891. The structures were designed as temporary installations. Facades used staff, a mixture of plaster, cement, and jute fiber painted white. Underlying frameworks employed wood and steel. The buildings were meant to stand for months, not decades. After the exposition closed in October 1893, demolition began immediately. Most structures were removed within weeks. A fire in 1894 consumed many of the remaining buildings. Only 2 structures from the original exposition survive. This pattern repeated at World's Fairs internationally. The 1851 Crystal Palace in London, the 1889 Exposition Universelle in Paris, the 1901 Pan American Exposition in Buffalo. Temporary construction, grand scale, rapid demolition. Contemporary accounts describe this as intentional. The exhibition showcased potential. The buildings demonstrated what could be achieved. Their removal after the events ended was planned from the beginning. Photographs from these expositions show something else. Electrical systems that appear fully operational rather than experimental. Infrastructure integrated into foundations, with a permanence inconsistent with temporary construction. Power distribution networks of a sophistication that seems to exceed what demonstration projects typically achieve. The electrical systems at the 1893 exposition required massive coal consumption to generate steam for the generators. This is documented extensively. George Westinghouse contracted to provide alternating current power. The competition between Edison's direct current and Westinghouse's alternating current systems drove the technology demonstration. Yet some photographs show elements that do not entirely align with this narrative. Existing infrastructure adapted rather than built new. Foundations that appear older than construction dates indicate. These observations raise questions about what was being demonstrated and what was being repurposed. Nikola Tesla conducted experiments in wireless power transmission between 1899 and 1906. His work focused on transmitting electrical energy through the earth and atmosphere without wires. In 1899, Tesla built a laboratory in Colorado Springs with a mast 142 feet tall. He demonstrated the ability to electrify the ground surrounding his facility and produce large electrical arcs. His observations led him to theorize that the Earth could act as a conductor if electric current was injected at the correct frequency. In 1901, with $150,000 from financier J.P. Morgan, Tesla began constructing Wardenclyffe Tower on Long Island. The structure stood 187 feet tall, with a 68-foot metal dome. Underground networks of iron rods and copper plates extended 300 feet into the earth. Tesla's vision was a global system of towers, transmitting electricity wirelessly. Anyone with receiving equipment could access power anywhere in the world. The system required conventional power input. A coal-fired 200-kilowatt Westinghouse generator was to provide the energy. Tesla was not generating free energy. He was attempting to transmit conventionally generated energy wirelessly. In December 1901, Marconi successfully transmitted a wireless signal across the Atlantic. Morgan became skeptical of Tesla's timeline and commercial viability. Funding ceased. By 1906, the Wardenclyffe project was abandoned. In 1917, the tower was demolished for scrap to satisfy Tesla's debts. The tower never became operational. At full scale, the wireless transmission of electrical power over long distances proved impractical. Energy losses increased dramatically with distance. The technology did not work as Tesla envisioned. This is documented historical fact. What remains open to interpretation is whether Tesla was pursuing an entirely new concept or attempting to replicate or improve upon systems he had observed elsewhere. His writings suggest familiarity with transmission principles that seem to predate his experimental work. The question is not whether Tesla invented wireless power transmission. The question is what inspired his specific approach. Photographs from cities worldwide show buildings with basement windows or below current street level, doors opening to staircases, descending beneath the present ground surface, first-floor entrances, now functioning as basement access points. The pattern appears in Boston, Paris, Edinburgh, St. Petersburg, and numerous other cities, with construction dating to the 18th and 19th centuries. One explanation attributes this to gradual urban development. Cities raise street levels over time for improved drainage. Rubble from demolished buildings accumulates. Infrastructure projects alter surface elevations. Multiple generations of street surfaces layer atop each other. Archaeological excavations confirm this process in many cities. Sediment layers correspond to specific historical periods. Each stratum represents infrastructure improvements, rebuilding after fires, or deliberate grading projects. Basement windows, partially below ground, were often designed that way. English basements and servant quarters were intentionally constructed at or below street level. This was common practice in 19th century urban architecture. These explanations account for observed ground level variations in ways consistent with documented urban development patterns. What they address less completely is the uniformity of this phenomenon. Why similar ground level changes appear in cities with vastly different development histories. Why the timing of these changes clusters around specific decades in the early 19th century. Some photographs show architectural elements that seem inconsistent with gradual burial. Windows with elaborate stone framing, now half submerged, entrances with grand staircases, descending from what were clearly designed as ground-level doorways. Whether this reflects rapid infrastructure changes, localized catastrophic events, or simply the cumulative effect of ordinary urban processes, remains debated. No geological evidence supports a single global catastrophic flood in the early 1800s. But localized events, rapid urban redevelopment, and coordinated infrastructure projects could produce similar visual patterns without requiring extraordinary explanations. The question is scale and coordination. Historical records document the rebuilding of Chicago after the 1871 Great Fire. The city was not fully reconstructed until the early 1880s. Economic recovery from the Panic of 1873 delayed completion. Developers spent nearly $50 million over 5 years. Full restoration required approximately 20 years. This timeline aligns with conventional expectations for urban reconstruction. Following catastrophic damage, other construction projects from the period show different patterns. Buildings described in records as major multi-year undertakings appear in photographic sequences spanning only months. Structures attributed to local governments or private investors exhibit construction quality and scale that seem to exceed documented budgets and labor allocations. The 1915 Panama Pacific International Exposition in San Francisco provides one example. Construction began in 1913 on land created through fill. Multiple grand exhibition halls, covering hundreds of acres, were completed within 2 years. Photographs show architectural complexity and infrastructural integration comparable to permanent civic structures. After the exposition closed, the buildings were demolished. This matched the pattern of other world's fairs: temporary construction for specific events, followed by removal. What photographic evidence shows is infrastructure that appears permanent: electrical systems, water distribution, and underground networks built with a durability that seems excessive for structures intended to stand for months. Construction records exist for these projects. Labor manifests, material orders, and budget allocations are documented. What creates ambiguity is whether these records describe new construction or adaptation of existing infrastructure. The buildings themselves provide limited evidence. Most were demolished. What survives exists primarily in photographs and written descriptions. This makes definitive assessment difficult. By the early 20th century, Tartaria had almost entirely disappeared from official geographic terminology. This transition did not occur suddenly. Maps published between 1870 and 1920 show the progression. Earlier editions used Tartary for regions later designated as Russian Empire territories, Ottoman holdings, or Chinese provinces. Encyclopedias revised their entries. Earlier volumes contain detailed descriptions of Tartarian peoples, governance, and trade systems. Later editions reduce coverage or remove entries entirely. The information is replaced with content focused on national and ethnic categories, aligned with emerging geopolitical boundaries. Libraries and archives reorganized collections during this period. Centralization of historical records under new governmental authorities led to reclassification of materials. Documents that did not align with updated administrative frameworks were often removed from public access, relocated, or lost during the political upheavals of the early 20th century. Academic curricula changed. History textbooks adopted streamlined narratives focused on nation-states and empires. Continental civilizations that did not fit this organizational model received reduced coverage or were omitted. This was not a single act of destruction. It was a gradual administrative process spanning decades. The effect was comprehensive. Within 2 generations, Tartaria, as a distinct geographic and cultural designation, had faded from common knowledge. Buildings attributed to this period remained, but their origins were reclassified. Infrastructure continued functioning, but its historical context was redefined. What was once understood as a connected system became isolated structures with localized explanations. Whether this process reflects ordinary evolution of geographic knowledge or something more systematic depends on perspective. Administrative reorganization produces similar patterns. Political consolidation requires updated terminology. Knowledge systems evolve as understanding improves. But the completeness of the transition raises questions. How thoroughly a widely used term can disappear, how quickly collective memory can shift, how infrastructure can persist while the context of its creation becomes obscure. The contrast between 19th century architecture and contemporary construction is striking. Buildings from that era display ornamentation and craftsmanship rarely seen in modern development. This difference reflects changing economic realities. Labor costs have risen, worker protections have improved. Exploitation that enabled inexpensive ornamentation is no longer acceptable in most societies. The trade-off is real. We have gained in human dignity what we have lost in architectural beauty. Modern construction prioritizes efficiency, safety, and fair compensation over decorative elaboration. This explains why ornate historical buildings seem difficult to replicate today. The economic conditions that made them possible no longer exist, yet observers examining these structures often conclude that the construction methods seem impossible given documented technological limitations of the era. This perception reflects present assumptions about what 19th century capabilities should have been. If labor was cheap and abundant, if materials were mass-produced and standardized, if large workforces could be mobilized rapidly, then elaborate construction becomes economically feasible, regardless of technological sophistication. The question is whether our present understanding of past economic and social conditions is complete. Historical narratives are simplified over time. Complex realities are reduced to straightforward timelines. Alternative explanations are marginalized or forgotten. Knowledge consolidates in institutional frameworks that prioritize certain types of evidence over others. This process is ordinary. It occurs continuously. It is not necessarily conspiratorial, but it does mean that what we understand as historical fact represents a specific curation of available evidence. Other interpretations existed. Other explanations were proposed. These alternatives fade as consensus narratives strengthen. The Tartaria question asks whether this process obscured something significant, whether administrative reorganization and knowledge consolidation eliminated perspectives that might have provided different understanding of 19th century development. The answer depends on what evidence is given priority and what interpretive framework is applied. We inherit knowledge systems shaped by specific institutional priorities. What is preserved and what is forgotten reflects decisions made by those who controlled records, managed archives, and wrote curricula. This is not inherently problematic. Knowledge must be organized. Information must be curated. Narratives must be constructed to make sense of complexity. But it means that historical understanding is contingent. What we know about the past depends on what was deemed worth preserving and how it was categorized. The observations underlying the Tartaria question are real. Architectural similarities exist across regions. Ground levels have changed. Construction timelines seem compressed. Geographic terminology disappeared. Infrastructure predating official records appears in unexpected locations. These patterns can be explained through conventional historical processes. Architectural education spread design principles internationally. Mass production made ornamentation economical. Urban development altered street levels gradually. Administrative reorganization updated geographic terminology. Infrastructure was adapted and repurposed over time. Each individual observation has a plausible explanation. What creates ambiguity is the accumulation of observations and the consistency of patterns. Whether multiple conventional explanations adequately account for what appears as a coordinated system, or whether that appearance of coordination itself requires explanation. Tesla's wireless power transmission failed. Wardenclyffe was demolished. The technology did not work at the scale envisioned. This is documented, but Tesla pursued the concept based on principles he believed were valid. His writing suggests confidence that long-distance wireless transmission was achievable. Where that confidence originated remains less clear. The 1893 exposition used coal-powered generators. This is extensively documented. The electrical system was conventional technology for its time, but photographs show infrastructure that appears fully integrated rather than experimental. Whether this represents remarkably efficient implementation of new technology or adaptation of existing systems depends on interpretation. Buildings were demolished after World's Fairs ended. This pattern is consistent and documented. But why structures built with apparent permanence were immediately destroyed rather than repurposed remains? A question economic explanations only partially address. The challenge is not choosing between mainstream and alternative explanations. The challenge is recognizing that both rely on interpretive frameworks shaped by assumptions about what is probable. Mainstream historical narratives assume that technological progress is well documented, that construction timelines are reliably recorded, that economic conditions fully explain architectural choices, and that administrative reorganization is transparent. Alternative narratives assume that knowledge systems can systematically obscure, that infrastructure can be inherited and misattributed, that coordination can occur without leaving conventional documentary evidence. Neither framework can be proven definitively from available evidence. Both make sense of the observations from different starting assumptions. What remains is the recognition that our understanding of the past is constructed, that buildings standing today carry histories we may not fully comprehend, that systems can disappear through ordinary processes that nonetheless produce extraordinary effects. The towers stood, the buildings were demolished, the terminology changed, the infrastructure persisted. What changed was the context in which these things were understood. Perhaps the question is not what was hidden, but what we no longer know how to see.